so you switch the...
Cut this out if I mess up this badly.
This year we had the pleasure to welcome Ulrich Nierste, who is a theoretical physicist from Karlsruhe University. And he delivered the lectures on the Standard Model and on beyond Standard Model theories.
In particle physics we have a luxury problem. We have a theory which is so good that we wish we would find deviation from the theoretical predictions in experiments. So the Standard Model describes almost perfectly everything which is measured at terrestrial experiments, but we know it falls short to explain cosmological effects, for example, that we have more matter than antimatter in the universe, or the dark matter is also not accommodated. So in order to understand particle physics and in order to be able to find new physics, one has to understand the Standard Model very precisely. So in my lecture I focused particularly on the symmetries which govern the Standard Model and the symmetries which are accidental in the Standard Model and might be the way to probe it to a level that at some point we find a clear deviation.
The first lecture that we had was about the Standard Model. That was pretty good. It was kind of a revision. Didn't really learn new things, but it was really organized and it was very enjoyable.
I presented a topic about the entropy. I wanted to go into a different topic, not related that much to particle physics. I'm still trying to get comfortable with those topics, but for now I try to cover a kind of more simple topic, which for me was the entropy. I try to put several segments about, for instance, I use the movie Tenet, which the main topic of that movie is the entropy. They try to prevent a war using entropy, like going backwards in time, and yeah, it's a very good movie. And I also try to use video games and other analogies to make it the more understandable possible, so we all can understand in a different way what is entropy, more than just a measure of a disorder. There's a lot of landscapes to see here. I think that reduces the pressure and the stress in us, the students. So it's very good. It's a good chance to to be like all the IMAPP and also other students be here. It's very good. I cannot complain. Like it's very, very good.
So today I gave a presentation about my time as a summer student at CERN, which was quite a nice time. I worked in a group which did a direct search for charged Higgs bosons, which is beyond the standard model. It's quite interesting. We did some upper limit setting on the expected cross-section at which we could find these charged Higgs boson, which was quite interesting to have in this field of study. It's really nice to be here on Corsica. The weather mostly is nice, the location is really nice. We have some pretty interesting lectures and also a pretty interesting project going on at the moment. Yeah, and I'm looking forward to the last few days.
Honestly, I enjoy the school in Cargèse here because it's very interesting. Right from my trip from Clermont-Ferrand to Ajaccio to Lyon, from Lyon to Ajaccio, and here to Cargèse. It was very nice experience from our arrival day till date. So we've been catching fun and having the lectures. Everything is going well. Yeah.
Second day in Cargèse. I mean, if you look at the photos that you have, this place is really beautiful. The island is great. You have hills. The views are really nice, and the lectures so far have been great as well because they're talking about things that are currently happening in research field. So it really puts things into perspective, like what you're studying in the course, how it applies to what is currently going on in the field. It really helps you understand why you're studying the things that you're studying.
My lecture about beyond standard model physics will start from the same point as my lecture on the standard model, meaning I look at the symmetries. So the quantum numbers which are connected to these symmetry groups of the standard model already point towards possible theories which might supersede the standard model. So a big field in this direction is the field of unified theories. So it might be that the true and more fundamental theory of nature has a bigger symmetry than the standard model, and one can derive predictions from those and check those. There's a sidetrack. Any model of new physics has a chance to have a candidate for dark matter, and there are several possibilities. They can be very heavy or they can be light, and that is another direction which one can pursue, even on a pure phenomenological basis, starting from experimental data and then trying to devise theories which accommodate these dark matter particles. I've been here as a PhD student almost 30 years ago, and I recognize many buildings. I also see that the school has expanded and there are new buildings. This is a wonderful place to be. It's close to the sea and it's also close to mountains, and it's a wonderful place to study and to attend lectures and also to give lectures.